Hello everybody, welcome to my presentation. Today we will discuss the data forwarding process in the network. Okay, from now on, we have discussed the layers of the TCP/IP reference model. The bottom layer, the physical layer, the second layer, the data link layer, and the network layer, the third layer, and the transport layer. Of course, the upper layer is the application layer. And then in each layer, we have discussed some protocols or standard. In the physical layer, we discussed the network media and the media access mechanisms such as CSM, CSMACD. And then in the data link layer, we discussed Ethernet, okay, the encapsulation of the Ethernet. And the third layer, we discussed the IP protocol. And besides the IP protocol, we also discussed ICMP protocol and ARP protocol. Okay, and then the transport layer, we discussed the TCP protocol and the UDP protocol. And then there are so many protocols. Then how do all these protocols to work together to sending the data from one side to another side, from one host to another host? Then in this chapter, we will analyze this, how all them work together. Okay. This is the objective of this chapter. First, okay, to explain the data encapsulation and decapsulation of the network. Okay, the data is how encapsulated and decapsulated. Okay, and then the data forwarding process in the network. Okay, this is the two objective, and then we got the scenario, network scenario. Okay, in this scenario, there are two hosts, host A, host B, in one network, and the two servers, server A, server B, in another network. Okay, then between these two networks, there's a routers and internet. Okay, then in this example, that's the host A wanted to access server A, and the server A is a server such as the HTTP server. That's the web server. Okay, that's the web server. Then how do host A sending the packet, sending data to server A, the whole process? Okay, we will explain this. Okay, first, the host A needed to send the data to server A. So the application layer first sending the data. This is the data of the application layer, then sending to transport layer. Okay, in the transport layer, you can regard this as a software, as a program. Okay, this program will deal with this data, just adding a header, adding a TCP header. Of course, maybe adding a UDP header. If the TCP header or UDP header added to data, it depends on the application. Okay, the HTTP use TCP. Other protocols such as DNS, okay, such applications use UDP, then encapsulate UDP. Okay, such as VDI encapsulate UDP. Okay, this is the TCP. Then the TCP header is added. The most important part is the source port and the destination port. We know that destination port is to identify the service that's provided by the server. Of course, HTTP, the destination port is 80. Okay, this is the default destination port. And the source port is random generated by host A, okay, by host A. And then the sequence number and all the other parameters, sequence number, acknowledgement number, and the window size are negotiated when in three-way handshake. Okay, the sync process. Okay, the connection establishment process. Okay, and then this is the transport layer finished its job, and then this data is forwarding to network layer. Okay, in the network layer just another program or another software. Then we are adding another header, the IP header, to this data. Okay, in this header, of course, this is the IP header, and the most important is the source IP address and destination IP address. The source IP address is the IP address of host A, and then the destination IP address, what? Destination IP address, just the server A's IP address. Okay, this is the destination. Okay, of course, there are some other parameters such as the TTL to avoid the loop in the network, and the protocol just to figure out the upper layer is TCP, so the number should be 6. Okay, of course, the TCP, the destination port 80 to identify this is HTTP. Okay, then the host A knows the destination should send it to destination. Then where to send? Of course, the host A should looking into the routing table of itself. Okay. Of course, usually the host, the routing table is very simple, just the default gateway. Okay, the gateway address. So this is the default gateway. The gateway is this address. Okay, this address just in the SAN network. Okay, so after the packet is encapsulated with layer 3 header, then should encapsulate with the layer 2 header. Okay, this is data, and then this is layer 4 header, and this is layer 3 header, and then should encapsulate with the layer 2 header. Okay, layer 2 header. Okay, then this packet, the host know what is the destination in the SAN network, then should encapsulate with layer 2. In the layer 2, there are 3 parameters. Of course, the type to point out this is an IP. So this is 0800. And then the source MAC address. Source MAC address is host A's MAC address. That's simple. And then the destination MAC address. Destination MAC address is what? Is the gateway's MAC address, just this MAC address. Okay, so we can see the address in a frame. There are 2 layers. The layer 3's address, just the destination of this packet, server A's address, and the layer 2 address, the destination MAC address, just the next hop's MAC address. Okay, then what is the destination MAC address? Of course, the host A first should look up into up cache. This is the up table. Of course, if found in the up cache the gateway's MAC address, then the IP packet should encapsulate it with layer 2 with this MAC address. If the host A not exist, this gateway's MAC address not exist, then the host A should use the ARP process to reserve the gateway's IP address. Okay, then after get the MAC address of the gateway, then the packet, the IP packet, is forwarding to layer 2, and then the layer 2, this is the IP packet, the layer 2 should encapsulate with the layer 2 header and the FCS frame checksum. Okay, and then in the Ethernet, if it's Ether2, then this is the destination MAC, source MAC, and the type. Of course, the type is IP, that's the 0800. Okay, and the source MAC is itself, and the destination MAC, okay, it's the gateway's MAC address. Okay, then after gets the MAC address, then this data can sending out. Okay, can sending out. Okay, when the data want to sending out, that means sending to the physical layer signals. So first, the data should have some fixed format. That's the preamble signals and the start of frame delimiter. Okay, that's the 10, 10, 10, and so on. That's the 5, and then there are the fixed 10, 10, and the last are 11. Okay, this is the start of the frame delimiter, and then this is to make the receiver to know what is the start of the frame. Okay, and then this frame can send into the physical media. Okay, before sending, we know to use the media, there's a mechanism we called CSMA CD. Okay, that means before sending, the host A should listen to the media that if there's others using this media. If there's others using this media, then hold on. If no one uses, the media is idle, then sending out. Okay, of course, should detect the collision if the collision is happened. Okay, then the data is sending out.